All right, we're going to show you guys how this works when we have unlike denominators. We want to have like denominators to be able to add two fractions together. So in your problem that you had on your document, it was 4/6 plus 2/5. So we want to model for the students how these denominators become the same down here on the bottom using this model here. In this first one, I have 4/6. So I'm going to take the 4/6, slide it down here, and I'm going to make it fifths also. I'm going to do it the other way in fifths. So I have my 6, now I'm going to separate this into fifths. And I can show the students now that I don't just have these 6 equivalent pieces or 6 equal size pieces, I now have 30 equal size pieces. My new denominator becomes 30. They can go through then and count and see that I have 1, 2, 3, 4, 5 times 4. 4 times 5 is 20 30ths shaded in. And you can show them that and you can demonstrate that and have them actually come up and count it out to see that my 4/6 is the exact same thing as 20 30ths. I didn't do any more shading or anything. All I did was made my units, my 6th, smaller into 30ths. I want to do the same thing over here with my 2/5. I want to make it the same. I want to make it out of 30. So this is separated right now into 2/5 this way, so I'm going to add my 6 this way. And I can show them again that I have 30 equal pieces. They can count how many pieces are shaded in, and it's going to be 12 30ths. 2/5 is the exact same thing as 12 30ths. There was nothing else added. The only thing I did was add my 6 this way, and I can see the 30 equal pieces here, 30 equal pieces here. 4/6 equals 20 30ths, 2/5 equals 12 30ths. And since I now have the like denominators, I can add this problem. Now when I add this one and I add my numerators, I get 32 30ths, which I already know that's an improper fraction. I can't have that. I want to change that into a mixed number, but that's going to come later on, and we'll show you guys how to do that later. So now we've done the model for them. Now we want to show them how that's really going to work over here. So I have 4/6 plus 2/5. What you want to do right here is just have a discussion with your students about multiplying by 1. When I multiply things by 1, if I multiply 5 times 1, I get 5. If I multiply 8 times 1, I get 8. Whatever it is that I'm multiplying by 1, I get the same answer. If I multiply 4/5 by 1, I get 4/5. What I want to do is show them here that I'm going to multiply by 1, but I'm going to use a fraction to represent that 1. So in this case, when I multiply this one to get 30ths, I got to think, what would I multiply that denominator by to get 30? Well, I know it's 5. Well, 5/5 is the same exact thing as 1, and your students will know that already. They know that 5/5 is the exact same thing as 1. So if I multiply 4/6 by 1, I'm getting 4/6, but it's going to look a little different over here. When I multiply this straight across now, I'm going to get 20 30ths. The same exact thing that I got down here, 20 30ths in our model representation. Now I'm going to do the same thing here, but I'm going to have to multiply this by 6 to get that 30ths. Okay? 6/6 is my 1, so 2/5 times 1 would give me 2/5, but I'm going to multiply it by a fractional unit of 1. So 2 times 6 is 12, so I get the same exact answer, 12 30ths, like I got here. All right? Now I can add my numerators because my denominators are the same. I'm going to get 32 30ths. And it's okay to go ahead and tell them at this point that this is an improper fraction, and we'll talk about that later, but we'll discuss with them how that works. When you do this generator, it's going to come up a couple times where you do have the improper fractions. That's okay. Let them put the answers like this because it is correct. And we'll teach them later how to make it a mixed number from this point. So that's how you could model this for them. And you could do this with several different problems. And they could even model it for you as an exit ticket or anything else you might want to use. If they can model this and show this, they've justified their answer in 2 different ways and are ready to explain how this process works.